Singularity.
Hello, everyone, and welcome to another edition of Singularity One-on-One. Singularity One-on-One is a podcast feature of Singularity weblog, where you can go and listen to it or download it in full. As you may already know, my name is Socrates, and as always, I am the man with the questions. Today, my guest on the show is Daniel Kraft. I met Daniel Kraft at Singularity University, where he is the head of the FutureMed Program, and he's one of those really fascinating people with a number of diverse accomplishments. He's a medical doctor, chair of the FutureMed Program at Singularity University. He's also an entrepreneur, an inventor, and an F-16 flight surgeon. So there's a lot of things that I would like to get Daniel to talk about today, but let's begin with your background. How is it that you got involved with Singularity University? And perhaps you can sort of trace the journey with all those diverse interests that you have.
Well, how I ended up at Singularity University is certainly a journey and not anything that could have ever been planned. So I guess I'll reverse back to high school, where we most often start with our interests. I've always had an interest in sort of gadgets, being a boy, fun toys, adventure, innovation. My grandfather and father were trained as engineers, though I'm not formally an engineer. I was lucky to grow up near Washington, D.C., and spent a summer after 10th grade at the National Institutes of Health, the NIH, and learned some early stages of how to be a basic scientist. And even though I was sort of mostly washing pipettes and helping grow cells that first summer, I learned some good skills. And to make a long story short, in 11th grade, we had to do a high school science fair project. I thought, I'll go back to the NIH, to the same lab. And I remember popping into my head an idea one day that we were, that summer prior, making antibodies to something called the IgE receptor, which is an important part of the allergic response, and came up with an idea to use some of those antibodies to block the normal response. And in the end, that actually worked out beautifully. We showed for the first time you could block IgE-mediated histamine release and cure allergic disease in a test tube. And that won the science fair in the county, and I went to the international science fair and all sorts of awards. And it's like, wow, you can take an idea from concept to proof and even win a prize. And that was sort of fun. The next year, went back and did it again. This time we put it into animals and showed we can cure rats of their sort of hay fever type allergies. And so that had implications and won all sorts of awards again. That wasn't the main point. The main point was, wow, here's an idea of some science that could be applied and maybe turn into a solution. The downstream lesson was, at that point, I thought, wow, maybe this could be used to cure or treat asthma. And back then, we weren't yet making humanized antibodies. They weren't yet in the clinic. So people said, good idea, but it's not clinical ready. And we published it. I forgot about it. And then 10 more years later, when I was a medical student at Stanford, I was called by Genentech, a big pharma company. And they basically developed that same approach to treat allergic disease, now a drug called Xolair. And they were actually in a patent dispute with another company and asked me for my first paper. So to make a long story short, I got interested in science, the application of science to the clinic, and learned that I probably should have filed some intellectual property and patents on those ideas. Now what I think is, $1 billion plus drug, but it often takes a long time to go from idea to innovation to crossing that clinical translation. Other sort of things, so I went off to college to Brown University. I'd followed other passions. I was interested in flying since I was a little kid. I actually was at the Apollo 17 launch when I was a little youngster. I learned to fly. They had a flying club there. It was $20 an hour, including gas to fly planes. I pursued lots of fun extracurriculars. Brown was a good place to have a sort of open curriculum, including looking at the clinical side of medicine. I became an ambulance sort of paramedic, an EMT, and so got to help be in charge of an ambulance crew and run around campus and mostly take care of drunken-induced injuries. But it was a good opportunity to see what it was like to be a physician or take care of folks in the clinical area. So I was melding the interests of aviation, emergency medicine. I was doing a degree in biochemistry. I went back and spent time at the NIH. So that being said, to answer your question, got interested in medicine, got interested in technology, innovation, invention. Left Stanford, went to medical school. Thought left Brown, was lucky to go to medical school at Stanford, which, like Brown, was also a pretty open, flexible place. And I would urge folks earlier in their careers to try and go to educational institutions which have some flexibility. It's great to take the classes and do well in those, but places like Brown, Stanford, other folks, arenas have so many other places and people to interact with. When you can mix it up, that's important. And to that point, my first year at Stanford Medical School, I ended up being the only non-engineer taking a class called Space Systems Engineering, so still following my space passion. I helped design missions to Mars. We were then working with the Soviets to date this, and we had Soviet engineers, we had Stanford engineers. I had to do all the life sciences. How do we get from Earth to Mars and back and keep people healthy? Do we have artificial gravity? What's the life support? Do we send a doctor? And that was a great multidisciplinary experience. And as fate would have it, one day I opened up the Stanford newspaper and there was a little advertisement for International Space University, ISU, and it was going to be in Moscow that year. And I thought, wow, first year medical school, what else would be fun to go join the life sciences department, have a chair of the department who was a physician cosmonaut, and mix it up with other folks. And ended up going to International Space University that summer, which ended up being moved to Toulouse, France. And as some of your viewers might know, ISU was co-founded by Peter Diamandis, who was also the co-founder of Singularity University. So I had an amazing experience in that 10 weeks or so in Toulouse, France. We designed a mission to Mars, which from the political side, the medical side, the space physics side, and it was a great experience to that degree. And thinking about big problems, big challenges, multidisciplinary approaches, both from the medical policy, ethics, other side of things, and met an amazing group of other kind of crazy thinkers and a community. And to sort of answer your question, years later, I stayed in touch with Peter Diamandis and many folks from ISU. I spent time meeting many of them at Johnson Space Center and having lots of interesting adventures. I later met folks who were flight surgeons in the Air National Guard and Air Force, and I went and did that. So I got experience being a doctor for pilots in an F-15 squadron at Cape Cod and then elsewhere. And that was sort of how that world pursued. I was pursuing my interest in science, innovation, space, wanting to be an astronaut, those things. And interesting things happened, including meeting Peter and other folks from that organization. And several years ago, was lucky to be attending the TED conference, reconnected with Peter. And when Singularity University was being started about 3.5 years ago, Peter asked me to get involved and help chair and push the medical neuroscience side of the track. So nothing that could have ever been predicted, but sort of by following interests and ability to mix it up with people, particularly from other realms. So ISU was a good example of meeting people who are not medical mostly, and getting inspired and connected and working with them, and staying connected to the sort of larger world outside of my more narrow medicine bucket. I was able to sort of stay interestingly connected and feel very fortunate to have had my opportunity to work with folks at Singularity U and all the folks and students and faculty connected to it.
That's a fascinating journey, Daniel. So let me ask you this then. So it seems that your original interest was in becoming a pilot. You said ever since you were a kid you dreamt of flying. You dreamt of flying planes. Then you sort of got interested in science, which eventually led you to medicine. So if you are to, and then you became an entrepreneur and so on. You had your invention for harvesting bone marrow. How would you qualify yourself then? Are you a doctor first? Are you a scientist? Are you a pilot? Are you an entrepreneur? A singularitarian?
Well, I think we all can get wrapped up in these I ams. I am this. I am that. If we're going to stick on the pure definition, yeah, I'm a physician. I did the full medical school at Stanford, plus extra research and time. Went off to Harvard and was lucky to do a combined residency in both internal medicine and pediatrics. And that was a big challenge for me in that I liked everything in medical school. I loved surgery. I loved psychiatry even. I loved emergency medicine, orthopedics. It was difficult for me to pick one sort of area because I was always inspired by multiple fields, and the thought of only doing laparoscopic cholecystectomies or even bypass surgeries or anything every single day, and it didn't exactly appeal to me. So, and I would also like, especially as a medical student or a resident, you spend a month doing one thing at a time, and you can often bring beginner's mind to that. You see things from a new perspective each time, each month. It's fresh, it's fun. So anyway, completed medical school, did the full, both combined residency. It was 4 years at Mass General and Boston Children's in internal medicine and pediatrics. Came back here to Hotel California for fellowships at Stanford in hematology, oncology, and pediatrics mostly. And then I did a fellowship in bone marrow transplantation, which is really a form of stem cell transplantation. So my time at Harvard, prior at Stanford, and back at Stanford, had stayed very connected to the stem cell and regenerative medicine world, which is where I sort of wanted to meld the world of clinical work and innovation and science. I never wanted to be a full-on doctor seeing patients every 10 or 15 minutes because I didn't think that would meet my sort of need for creativity and innovation. But being back at Stanford in this very rich entrepreneurial environment, with Sand Hill Road, with the engineering school, the business school, the law school, all here, created a nice niche for that as well. So while doing my standard medical training fellowships, I was part of the first year of the Stanford Biodesign program. And Stanford Biodesign was a very unique program, now being expanded and kind of cloned across the world in other places, that asked three things. This is important in any field. What is really the unmet need? And in a clinical problem, in the medical world, for example, and I'll share with you my unmet need, and I'll tell you how that evolved. But first, clearly identifying what's the real problem, not having a technology and trying to apply that to the problem, but really understanding the problem. Who's doing it? Who adapts the new tool, or the toy, or the app, or the device? Understanding that really well, then innovating a solution, and then getting it out there in the world. So my unmet need as a bone marrow transplant fellow was how to do a better bone marrow harvest. I spent a lot of time in the operating room. We basically take a big needle trocar about this size and poke it into the bone marrow cavity several hundred times under general anesthesia to get about a liter of bone marrow used for bone marrow transplantation. You can see a short TED talk on that if you'd like a better description. I ended up thinking of a better way to do that, innovated and invented a device called the Marrow Miner, which really eventually got through FDA and CE mark trials, and hopefully we'll get to the actual clinical market soon as a better way to harvest bone marrow stem cells, not just for bone marrow transplantation, a form of stem cell therapy we've been doing for 40 years, but also for a whole slew of regenerative medicine applications, which in some cases are using adult stem cells from the bone marrow or other places. So biodesign was a good example. So what else am I? So I'm a physician. I've been a scientist, spent a lot of time in the laboratory at Stanford and other places looking at mostly adult stem cells, how they develop, their niche. We published in Science a year or two ago a way to create sort of an artificial bone marrow underneath the kidney capsule and grow a complete bone marrow environment, discover the cells that would create that niche. Together with Charles Chan and other colleagues at Stanford, we developed another technique to use antibodies, not for treating allergies, but to knock out the normal stem cells or the disease stem cells so we could replace those with healthy stem cells, which has applications in longevity therapy, for example. So been a physician, spent a lot of time treating patients, also like the overlap with the research side, and also the entrepreneurial side. Often it's difficult to innovate in the academic world as much. Stanford is a reasonably healthy place for that. And then sort of was blessed to get that sort of side gig at Singularity University over the first couple of summers, guiding the medicine track, from which our newer program, FutureMed, emerged.
That's very interesting. And, the reason why I tried to ask you to identify who you are is to give us a glimpse at what is your motivation, what pushes you, what makes you tick. So if you were to put it in a sentence or two, would you say that's like helping people, helping others, alleviating suffering in the shape of your medical career? Is it pushing the envelope sort of and coming up with new tools and gadgets, as you call them in the beginning, at the cutting edge of technology with your scientific background? Or is it to have fun, which I would imagine is the reason for being a pilot?
Well, I think it's always important to have fun. Being a pilot and flying has always been a lot of fun. It's been fun to fly little planes, and then when I got the chance to be a flight surgeon in the Air National Guard, to get to fly in fighter jets, of course, that's fun. And I'd say always sort of follow your passion and follow your bliss, and you'll end up in interesting places. Even if you don't end up on the moon, you'll get close or somewhere interesting. So I think what drives me is, in terms of bigger picture, is impact. I would probably feel frustrated being a pure everyday doctor, and that's a wonderful thing to do, but I want to, I think, achieve larger impact, hopefully across healthcare. And for me, it's most fun when I get to do that with other people, mixing that from other fields, hopefully educate and inspire them a little bit about what's possible in medicine and science and healthcare, or what the problems are. So it's simply fun for me to sort of be a cross-fertilizer, to bring people from the worlds of AI or robotics or IT or gaming or gadgets and go, to some degree, let them know what's happening in medicine, what the big problems are, what the reality is. A lot of people have a beginner's mind and a naivete about what can be done in healthcare and medicine, which is great. We need those sort of beginner minds, but it often has to be grounded in some reality. I mean, listen, that's what's really what happens in the clinic or in the operating room or in the emergency room. It's not as simple as having this technology and plugging it in. So there's that angle. I like being a connector and seeing where there are opportunities between different fields, even in medicine. And one thing that happens at Singularity U and the FutureMed program based there is we bring people from even different realms of medicine. So I'm trained as a hematologist oncologist. I'll go to the ASH meeting, American Society of Hematology meeting every year. But by doing that medical device project, I end up going to cardiology meetings or even neuroscience meetings. And when we bring folks to Singularity U and FutureMed, we have physicians from multiple different specialties, often who never speak to each other outside of maybe the pure consultation role in the clinic. And they get to see where might the area of imaging match their area of interventional cardiology, meet AI, meet big data, meet apps. And then they'll talk to somebody who's working in synthetic biology and vaccination and global health and say, wow, these things might connect in ways that they never imagined. They see where the puck is going a little bit, where the trend might be in artificial intelligence in healthcare or synthetic biology or mobile apps, and go, wow, my problem might be addressed maybe in 6 months by putting these things together. So part of my role is sort of being an instigator, an educator, hopefully seeing where different threads are going, a bit of a connector. I've been labeled a bit as a futurist. I don't necessarily think I don't have that I am hat on, but hopefully I get a little bit of a perspective on where things are heading and where the problems are and how certain technologies and convergences can come together. And I think that word convergence combined with exponentials is where things get interesting.
That's very interesting that you said about your interest in healthcare and where things are heading. And one of my new friends here in Canada is the head of an organization which is working on reshaping or saving Canada's healthcare. And they have a portfolio of about $35 or $37 million. And actually, he's very interested in the FutureMed program at Singularity University, and he was going to attend, but his wife was unfortunately going through fighting cancer for the last few months, and now successfully she pulled through, which is amazing. But I would actually, that reminds me, I should connect you two guys, because you do have a lot of things in common, and he would eventually come and join you there at the FutureMed program, for sure. So perhaps now is the time to tell us a little bit more about what FutureMed is. What is the goal? What is the program? What's the purpose? What's the structure? What's the process for those of us who are interested in joining you?
So as you know, at Singularity University, we've had 3 summers, 10 weeks, to look at AI, medicine, robotics, IT, healthcare, space, energy, and approach big problems. And not everybody has 10 weeks, and not everyone can get there. We've also been lucky to do every quarter or so executive programs that, again, cross the multiple spectrum, but are limited to 7 days, usually for folks a little more advanced in terms of age or experience than those who come to SU, the summer program. And, lucky for us, the medicine track has often engendered a lot of the interest in terms of all the cross threads that come together from participants who come to the program. And but the problem is we only have like 4 hours to cover medicine in that week, plus a couple little side visits or workshops. And Peter Diamandis and I were both at the TED Med conference a year ago. We've both spoken at TED a couple of times and TED Med. And the TED conferences and TED Meds are fantastic, but they're kind of limited in a sense in the format, 18-minute talks, short talks, but they're not often connected. And we thought, wouldn't it be interesting to take the Singularity U executive program format and look at those core tracks that might affect healthcare and do a focused executive program, which eventually we ended up calling FutureMed at Singularity University, to focus on where can fast-moving technologies, not just exponential technologies, but I'd say rapidly developing technologies, especially when they come at a convergence, how can they change prevention, health, wellness, diagnostics, and therapy, and medicine in general. So that was the idea of FutureMed converged in a sense that we might be able to take the lessons of SU in the format and have a little more of a deeper dive in curriculum than you can get at a normal executive program or some of the things you get at the wonderful TED and TED Med programs. So that's where the idea for FutureMed came together. We pulled together a working group, some track leads like we've had for SU in general, and last May did our first FutureMed, which was 5 days essentially. And we have essentially, kind of like Singularity U, some core tracks, genomics and personalized medicine, again, something moving very quickly, and we're now down to essentially $1,000 genome, so definitely exponentials at play. Data-driven health and the web, all the elements of people using big data and connected health, whether it's teleconferencing or telemedicine as an example. We have a track on regenerative medicine, layering into that a bit of aging and longevity, stem cells and related arenas. We have a track on neurotechnology and neuromedicine, a lot of things actually happening there from imaging and new approaches for Alzheimer's and Parkinson's. We have a track on simply the practice of medicine. How does this all come together to change how we're going to innovate? We talked about, or we mentioned, healthcare economies in Canada and elsewhere are in big trouble. And just published last night was a study that many of the major economies are going to be downgraded if they continue on their track of spending with the aging population. So it's almost like innovate or die. So how are we going to practice medicine and give access to the many folks who are underserved today can be leveraged through technology. A couple other tracks, including global health, many elements of how first world medicine and technology can now be layered almost directly, in some cases first, to the developing world. Innovation can in some ways happen faster there. So those are a few of our tracks. They're all illuminated on the website, FutureMed2020.com. And one thing that's special, as you'll know, and some of your listeners about Singularity U, is we're not a conference. We're not 200 or 500,000 people. We're limited to about 80 full-on participants, and we have about, this time, 60 or a little over 60 faculty coming in and mixing it up over the week. And we have an environment where you can have discussions and conversations and Q&A in a way you can't do at a big conference. We can do workshops on innovation, site visits. We'll go to Intuitive Surgical, which is a leading robotic surgical company. We'll go to Kaiser's Garfield Innovation Center, where they try new innovations in sort of in-house and look at how it works in the real world. We'll go to Autodesk and look at 3D printing and design. So things we can do with a small intimate program that you can't do elsewhere, and bring a mix of people and ideas together. I'll mention one thing that we're doing a bit differently that others might want to do in their other kind of programs is we're mind mapping the whole event. We did this last time with one of our faculty, Jim Caravella, who spent years mapping his mind and other connections. And by sort of connecting the speakers, the ideas, the companies, the technologies, the academics, the needs, the solutions, and sort of a living mind map, we hope to kind of create a living entity that can be shared in the Singularity U, FutureMed world, and beyond to help spur innovation and see where things are sort of heading to help connect dots.
So you have this incredible ratio of 60 faculty to about 80 attendees.
Right.
That's unheard of. That's almost one-on-one.
Almost one-on-one. And a lot of the faculty end up staying there the entire week, or the ones who can't stay are like, oh, I wish I was staying the whole week. I wish I knew.
That's absolutely unbelievable.
Right. And we all live there on the NASA Ames campus, which is good. So you have the ability to stay up late, have some bonding in the bar, and have some of those cross-fertilizations of conversations you don't get, if you're at a big conference center, or even if you're in a hotel. I mean, there's something different about being on the NASA campus and in the Singularity U, classroom space that facilitates things that don't happen most other places.
I can vouch that some of the best memories that I've taken from my time at Singularity Universities were from the computer lab at 2 a.m. with a bunch of people discussing the future of humanity, or in the main auditorium, or what we called the Voodoo Lounge at some point. Yeah, so I highly recommend it. But let's get back on topic here. I know that the current edition of the FutureMed program starts in just a few days, but for those people who would like to join you for the next one, do you have any idea when it would be and how they can begin the process of looking into it and perhaps applying?
Sure. Well, first thing, we have a fair amount of material from the last FutureMed up on the website at FutureMed2020.com. It's also linked from the primary SingularityU.org website. And I would encourage people for some content. We have a videos link of some of the faculty, not the full-on talks, but we asked them to give like a synthesis, like 5 minutes on what did they just talk about. Those were beautifully produced with our co-partners at Doctors Channel. So there's some nice things from Tim O'Reilly talking about where big technology and crowdsourced information is taking healthcare, to Thomas Getz from Wired, looking at feedback loops, to Ronnie Zeiger from Google Health, to others. Some of our faculty from last time, some of them are coming back, synthesizing some of their talks. So there's some online content there. Some of the takeaways from last time. So there's like one-liners, like in the future we won't prescribe drugs, we'll prescribe apps. One of my little takeaways. Or in the future we may be 3D printing complex organs. That might be a takeaway for someone who doesn't know much about 3D printing or regenerative medicine. So we have a kind of a listing of some of the takeaways to look at from the last one. We'll be doing that again this time. There's a newsletter to sort of sign up for, which we very occasionally use, but we'll make sure you're aware of when we run the next FutureMed, which will either be late this fall or more likely again early next year in 2013. And we'll keep it at that. So sign up on the email list. We'll keep you apprised. Follow us on Twitter, FutureMedTech, at FutureMedTech, and our Facebook group, which is just facebook.com/FutureMed. And you'll get occasional updates, interesting articles, sharings. We will also be live streaming the first full morning of FutureMed on the morning of February 9th.
Oh, that's fantastic.
February 7th, Tuesday, is our introduction to exponentials. So a lot of the participants coming into FutureMed, about half are physicians, half are not. Many have experience with exponentials, many don't. So we're doing a not fully medical focused meeting, but morning, but focused on exponentials. We'll be started with an hour of Ray Kurzweil. He'll be teleporting in with Q&A. Then we're going to do several short talks on the future of AI with Neil Jacobstein, who chairs the AI track with Dan Barry. We'll have Dan Barry talking about 3D printing and robotics. We'll have a talk on IT and the web from Salim Ismail, who's the first executive director. And of course, on nanotechnology, Ralph Merkel. So we'll have several. We'll be anchored by the amazing Ray Kurzweil and their amazing core SU faculty, kind of giving short introductions to exponentials and where they're heading and how they touch on medicine. And we'll close that first morning in that live cast, which hopefully you and your viewers can join if the technology works, with a closing talk by the co-chair of bioengineering at Stanford, Dr. Stephen Quake, who's a real pioneer across exponentials, including microfluidics and shrinking labs to microfluidic chips, which is now becoming a real game changer in medicine and other fields. He's co-founded a couple companies, including Fluidigm, to do that. Was one of the first people to have his full genome done and to look at the implications of knowing what your genome is, together with several of his smart doctors and colleagues at Stanford. What do you do when you present with a genome? Still a big question. So our first morning, I hope folks can join us, 8:30 a.m. Pacific Standard Time on Tuesday, February 7th. And it will be streamed from the SingularU.org website and FutureMed2020.org website, or .com.
Fantastic. So during the previous question, I lost the audio for one little second. So you may have addressed that point, but I want to reinforce it even if you did. And if you didn't, I don't want to miss it. The goal of Singularity University Graduate Studies program is to basically come up with a project, with an entity, ideally a company, which would impact positively the lives of 1 billion people within 10 years. So that's the stated goal. That's what it's all about, making a difference, making a dent in the universe. What is the goal of FutureMed program?
So from my perspective, wearing the hat of sort of executive director, it's a great question. I think there are going to be different goals for different people coming to the program. From my perspective, I want to think about and educate and cross-fertilize sort of movers and shakers across the spectrum, not just doctors and healthcare people, to recognize, number one, what are some of the big challenges across healthcare? We know some of those already: obesity and bad habits and changing habits, to aging demographics, the needs for impacting problems like Alzheimer's, et cetera. We know there's lots of problems in healthcare, but getting people up to speed with what are the sort of the cutting edge technologies that can affect medicine, not even the traditional ones necessarily, but where are the trends heading in personalized medicine and genomics? Since last year's FutureMed, it was about a $10,000 genome, and now we're at a $1,000 genome. What can we do with that? What are the opportunities and challenges to apply that to, let's say, cancer. Big problem, curing cancer. We'll talk about how we might get to personalized oncology. If we're at $1,000 or $100 genome, how soon will we really be sequencing every single tumor, sometimes multiple times, to pick the right cocktail of drugs, or be able to synthetically derive a very specific therapy to an individual's very unique molecular fingerprint or set of pathways that could be best treated. That's one example. So to more succinctly answer your question, I would say the goal of FutureMed, from my view, is to educate and inspire people to see where technology is heading, where it can interestingly converge, and how it can really start to speed up innovation to address big problems across health and medicine. And that might be better prevention, because I think if we spend our time and money and attention on preventing people from getting sick, and that can use a lot of technology, from apps to virtual reality or augmented reality. If you look in the mirror in the morning and you see your healthy you or your unhealthy you, that can really change your behavior. If we leverage smart wearable devices, the quantified self movement, dashboards, better user interface, better design technology, better psychology, we can affect that whole sort of prevention field very dramatically. We need to start getting the payers involved, big insurance. One of our lead speakers will be the head of Medicare and CMS for Region 9, which is the largest Medicare region in the US, and they spend most of the dollars on paying for chronic disease. So they have a big incentive on better care at lower costs. So it's a complex answer, but I would say we should hopefully be able to speed up innovation, let people have a better vision as to where things can go, and hopefully address big problems going forward in more collaborative ways, and make relationships, and maybe new companies will spin out of this, and some sort of have, just like from the summer, that can address big problems. One of the spin-outs, in a sense, from last summer was a company called Scanadu, which had just formed right before FutureMed, but made many new connections and fundings and ideas that is spurring them to address the new X Prize focused on creating a medical tricorder, which is an example, the tricorder X Prize, of exponentials at play. How do we shrink all those technologies into essentially a mobile phone to enable better point-of-care diagnostics in a less invasive way?
So let me ask you this then. Have your ideas about medicine in particular, let's bring it even here, longevity in general, evolved since the time that you originally joined Singularity University and founded the FutureMed program?
Sure. Longevity is a really interesting field and not a problem, but area to attack. And Aubrey de Grey, who's on faculty at Singularity U and will be there this FutureMed session, together with Sonia Aronson, will be doing a session on longevity and aging. And I've never sort of defined myself as a singularitarian. I'm very interested in all those concepts and the singularity per se. I've never personally been, pursuing, as I get older, I'm more interested potentially, but I've never said I live to 200, 300. I haven't had that goal necessarily for myself, but I see the appeal for many people and the opportunity to, we spend so much of our time and money and economy on treating the very chronically ill and the very sick at the end of life. And there's many opportunities to improve health span. I'm much more interested in having healthy, not just longevity per se in years, but effective, integrated, engaged lives. And so I think health span is where I'd probably be, health lethargy, a new term, rather than just longevity. But from my hat running the medicine track at SU and at FutureMed, I've seen a lot of new technologies coming downstream, and I'm getting a much better appreciation for how quickly they're moving, whether there's elements of telomerase and measuring and manipulating that world, or the world of synthetic biology, or how quickly my field of regenerative medicine is moving and how things can apply there. The folks in the SENS world and Aubrey and other worlds have done a nice job of, let's take a looking at aging per se as a mechanistic process, and how might we attack that from different fields. Just like I'll put my cancer doctor oncology hat on and say, we can't treat leukemia or lymphoma or lung cancer with one drug. We have to attack it from multiple angles to affect different mechanisms in that path, and hopefully make it very specific to that individual's tumor. We need to do the same thing for longevity, and that's going to be understanding someone's genome very well, their environmental data, which can be influenced or measured by their mobile phone, for example, or sensors. It's going to be better ways of monitoring their diet, environmental issues, all those sorts of things coming together can be applied to affect longevity. There won't be any one silver bullet. Resveratrol is interesting, but it's not going to be the full, as an example, approach. So I think there's something there about that escape velocity for longevity that's been talked about by Ray and others. And many folks who come to Singularity U and FutureMed will be pursuing that. And by putting those threads together, just like we want to treat a cancer very differently, I think we'll optimize the cocktail for you or me in terms of optimizing my longevity. And that might be very different from individual to individual. And many of the exponentials at play that we'll be talking about and are exploring will create new opportunities to address that.
So when I interviewed Aubrey de Grey for this podcast, I interviewed him twice, and on the first interview he said that longevity escape velocity may be closer than we think. What would you say about that statement? How do you see that?
I'm an optimist. I would love to think it's closer than we think, and I don't know what the current number is. Medicine, unlike other technological fields in healthcare, does a lot of challenges, and I am definitely an optimist. I want to push things out there, but it's by its nature challenging for some good reasons. We do have a regulatory environment. You just can't throw a new drug or device or invasive procedure out there in many cases. Our responsibility is to make sure things are safe first, sort of the do no harm Hippocratic oath. So it does take longer to get new innovations, drugs, therapies, devices, really that are truly effective into the medical realm. I think we need to help reinvent and innovate, let's say, the FDA process. And the FDA, to its credit, is really looking at how to take these new exponential technologies. Things are evolving quicker than they can regulate or address, whether that's synthetic biology or regenerative medicine or others. So the escape velocity, to some degree, is going to be determined by how quickly we can innovate the process of innovation and trials. And trials in the future won't be the standard phase 1, 2, 3 with hundreds or thousands of patients. They might need to be to an N of 1. Again, your longevity cocktail or chemotherapy regimen might need to be very specific and different, and that can't be measured in the same ways. So it's going to be frustrating for many of us that there can be some great innovations. Some of the things we talk about, some of the things that exist already today are still going to in some case take 5 or 10 years to get into the clinic. And hopefully part of my mission and others is to help push that a little bit faster, but still do that in a safe way. So the escape velocity sometimes will surprise us. Maybe one thing can happen in a few years. Just like 10 years ago, we probably couldn't have predicted Twitter or Skype or YouTube or Facebook. We don't want to, especially those of us in this conversation, we don't want to be limited to our linear thoughts. But I'm hopefully in the next 10 to 15 years, some other big leaps will happen. So in 10 years, we'll have this conversation through a very different connection and go, I can't believe this already happened. And part of what Singularity U, FutureMed, is to get people on that wavelength and mindset. So I don't want to give you a prediction about when the escape velocity is going to happen, but I think it'll be an integration of multiple different arenas, and it's not going to be one size fits all, and it's not going to lead to longevity or health spell for all. But particularly if we spend attention, money, and effort on that prevention side, that we're not curing cancer, we're preventing it from happening. We're not curing diabetes, we're getting anybody off of that pre-diabetic path. Sometimes using simple apps, behavioral modification, virtual reality, points, gamification, all those smart things we talk about at SU to impact that can influence lifespan dramatically and get people to 20, 30 years from now when we really are printing your own organ from your own stem cells, on demand at the price of $100.
So pushing longevity to the side, what is the most exciting field for you, which is at the crossroads between medicine and technology at the moment? Is it regenerative medicine in general? Is it something like tissue engineering, bioprinting, perhaps stem cells, personalized medicine that you've mentioned? What is it that makes you most excited and most optimistic about the future, that you think we're almost there?
Well, depends where you're almost there is, but I think it's a wrap of those things. I mean, we have these little buckets, and that's one of the challenges in the practice of clinical medicine, in the practice of biomedicine, science in general. Is we're very domain bucketed. I was back at Mass General Hospital for a reunion about 2 months ago, and the halls were the same, the departments were the same. In some ways, we need to reinvent how we define clinical fields because, you go see a gastroenterologist or a cardiologist or a dermatologist, and we're all these little buckets. And the future of healthcare, medicine, longevity is going to be integration of convergent fields and where they touch up upon each other. So it's not just personalized medicine or regenerative medicine. So I'm most excited about where they come together. So the future of personalized medicine will be in one vision, and this isn't the exact solution. Let's say taking the world of stem cells, the ability to take any skin cell that you have, reprogram that to be the equivalent of an embryonic stem cell, because we all have the same DNA in our cells as we were in an embryo. It's how they're turned on. It's not just the base genome, it's the expression of those genes that are important. So we can now reprogram almost any cell in your body to go back to being an equivalent of an embryonic stem cell, the iPS cell, induced pluripotent stem cell. That's a field that's moved really exponentially from being just sort of modeled in mice to now human cells to being very quicker and more efficiently being able to be done, not yet in an FDA safe, clinically applied way, but we'll soon, I think, get there. Combined with, so that's personalization in your own cells. Two, we need to make those, let's say, in an organ that fits you, whether that's a kidney or a liver or more simple structures like just last year, the first trachea was reconstructed essentially with sort of 3D printing, seeded with the patient's own progenitor cells, not from iPS cells, but progenitor cells, could then essentially regrow a personalized trachea, a pretty simple, essentially organ, hollow. It doesn't need to be vascularized, but that could then replace one that was damaged by cancer. So that's an early example of something that's happened in a couple situations, in a couple case studies. But it's where those merge together, the ability to bank your own stem cells, maybe create your own cardiomyocytes, hepatocytes, neural cells, put those into the constructs of where we can use those clinically. Because we can't just squirt in most stem cells and have them grow into a kidney or liver or a patch of heart. They need to be integrated with bioprinting. And maybe we need to print your own personalized organ, in a sense, with different layers of the molecules, the structure, the different types of cells coming together to grow a version of that can be implanted. Or maybe that's going to be printed internally. That we don't need to be a failure to our imagination to think this would be printed in addition, plugged in. Maybe it's a matter of just reprogramming the cells in your body to regenerate that liver or kidney endogenously. That will be the real holy grail from that side. So I guess I'm most excited about the integration of 3D printing, bioprinting, stem cells, personalization. That's sort of one example of where it can all come together. I'll just mention one other sort of big sea trend that pulls these things together from the less medical side is that of the digitization of health. We're now in this crux on the hockey stick of digitizing records. I'm not sure in Canada, but in the US, we're less than 30% of medical records are digital. And that's changing through the incentives that the Obama administration and others have set up. And I also like to quote one of our Singularity U and FutureMed faculty, Dean Ornish, which says, we don't practice evidence-based medicine, we practice reimbursement-based medicine. We get, doctors are going to do what they're incentivized to do. A doctor's not going to do a Skype call with their patient like we're doing there unless they have some way to bill for it. I mean, I might be the nicest doctor in the world. I can spend all day Skyping with my patients, but if I'm not paid for it, I can't run a clinic. Yeah. So we need to have the insurance companies and others get on board with technology like the digitization of records and getting people incentivized to doing that, which is why the Obama administration is paying $40,000 to have doctors go sometimes through that painful process of going through paper charts to electronic. And then when we have electronic records, they can emerge into electronic systems, not just records, where they can then crowdsource the data and know your genetic information, compare you anonymously and privately to others that are similar to you in certain ways, and know that other patients in Canada who have their own internet shows who take this drug and these genetics do particularly well with this approach, as an example, and learn to iterate much more quickly, or take lessons that are learned and published in New England Journal and get them to the clinic much more quickly. So the digitization of data, the ability to share it, crowdsource it, socially connect it. There are now Facebooks for doctors like Doximity and others to connect clinicians. All those things together with the digitization of your genetics, your proteomics, and hopefully eventually connected to smart AI-enhanced systems, as exemplified by the folks at IBM Watson, who are now applying AI to healthcare, as have others, can be big game changers.
Fantastic. So time is advancing, and I know you're a very busy guy, so I'm going to try to wrap it up with the next couple of questions. But let me just ask the reverse coin of this question. Is there something that you're most worried about? I mean, you said you're an optimist, and I have the highest respect for that, but what is the thing that concerns you the most within that field? Is there any such thing at all to begin with?
Uh, well, again, everything across healthcare is so broad. There's no sort of always one thing. But I would say one of the things I'm sort of concerned about, but I'm a bit of an optimist towards, is that if we're in the Western world and it's all driven by the payer who pays for it, there's sort of that cynical thing. You might have the coolest new toy, gadget, medical device, drug. The question is who's going to pay for it? There's a lot of great innovations that have come out of SU or medical incubators. The question is who's going to pay for it? And part of the innovation that needs to happen is pulling together, not having insurance companies change their view of, well, I'm not going to bother doing prevention because they're going to change insurance plans in 2 years anyway. But when we start getting the big Kaisers of the world, the VA systems, some forward-thinking payers, insurance companies going, wow, if we start really focusing our exponential technology skill sets on better connectivity, social networks that encourage better behavior, whether that's preventing disease or managing chronic disease in smarter ways, and enabling the cross-fertilization and rewarding innovation and new companies and new ideas earlier in that process. So they don't need to spend $1 billion to get that blockbuster drug out there, that one-size-fits-all drug, but can start personalizing healthcare and medicine from the detection, prevention, therapy side, and starting to play together. And I think we're sort of in this one big boat wherever we are in the world that we need to innovate or die, in a sense, and to move into this world of abundance that Peter Diamandis talks about. Takes some sort of bigger structural, sometimes policy realms, and not falling into the fear camp, the fear of medical privacy data, or, oh my God, what are we going to do with synthetic biology and create the next, killer virus? Those things we need to pay attention to and be mindful of and plan and think towards, but not to fall into the fear side. So I'm not sure if that answers the question. I would say I think it's a matter of pulling together a lot of the convergent, sometimes folks in parties that don't play well together and are sometimes going to lose. I mean, some fields will be disintermediated by these exponential game-changing technologies. There's a new book out by Eric Topol called The Creative Destruction of Medicine. A lot of fields of medicine are going to get destroyed in some ways, and there are going to be a lot of powerful lobbies and players against that. I sometimes give the example, not to make fun of dermatologists, but dermatologists are great doctors, but they do pattern recognition. That might be supplanted by my simple app that can take a picture of most rashes or moles and go, oh, that's a melanoma, that's not. It then's going to send to the smart dermatologists. They're going to get a feed of patients who have real problems. But some fields are going to change dramatically. Radiology and others that are going to be, in some cases, augmented, but in some cases supplanted by smart technology. And there's going to be a lot of friction there as those things meld. So there's a note of caution, hopefully later with optimism, that we can lead to a better biomedical healthcare world. But some people are going to sort of initially lose in that, and some people are going to have challenge with the change.
Fantastic. So the very last question that I always ask of my guests is this. Is there a single message or a single point that you would like our viewers and listeners to take away from from our interview today? What's the most important one thing?
I think one of the themes I've learned from spending time at Singularity University and from sharing the FutureMed Program with some extraordinary folks and teammates and collaborators is that taking the medical healthcare, neuroscience focus, which again is very broad, is that, wow, there's some incredible things happening across technology, and that you don't need to be a doctor or a biomedical informaticist or a pharmacist or to play a role in health and medicine and improving healthcare, however you want to define that. And that you can be a person in games, in IT, in mobile, in AI, in robotics, in nanotech, in big data, almost anything, and apply your passion in that area to some degree in healthcare, or see how it can play a role in healthcare, and see on all these exponential trends it might plug in now or in a couple of years. And to think about how you might leverage your own skill set, experiences, technological abilities to affect in positive ways, prevention, diagnosis, therapy, treatment, And we can really end up with a much better world across the spectrum, but particularly in the medical healthcare world, by sort of applying our different skill sets and imaginations and convergences to create a new and better healthcare world.
Daniel Kraft, thank you very much for taking time to be with us today.
Thanks. Great to be here. Hope to see you in future adventures, and hopefully you can all connect with us in person or otherwise through Singularity University and FutureMed, FutureMed2020.com. Thanks a lot.
Thank you.